create a create situation and they ask questions on the basis of it. So I put my first concept. What is a projectile motion? Projectile motion is an example of a two-dimensional motion, horizontal and vertical motion. Like if I throw a ball like this, the ball goes up and the ball goes ahead also. So it means a projectile motion has two dimensions. Look at this, a horizontal dimension and a vertical dimension. So when you throw a ball like this, the ball goes forward and the ball goes up also. This is called horizontal and vertical displacement. This motion is called projectile motion, like this example and the famous game Angry Bird. Have you played Angry Bird?
Yeah, a lot.
Very good. So do you remember that how
Very
we
good.
use? It's a very nice game. It's a very nice understanding game. And you will, these games, some games are helpful. Obviously, playing a lot is not good, but some games like which involve some thinking process and no type of violence are good games. Now, do you remember that how you used to control this throw?
Yeah. I used to align it at maximum height, like
Mhm.
tilt it just this much, and
You mean
pull
maximum
it as
stretch?
much as possible.
Hmm. It means it's a maximum stretch.
Maximum stretch and at the like steepest place so that it can go high.
So is it necessary that we throw high, we throw it high always?
No, depends
Very
on
good.
the place where
Situation,
the
a target.
target is.
Achha,
Yeah.
now, do you like football?
Football, yeah, I do.
So here my question comes, what how these people control the football kick?
They like mentally they calculate the number. No, they calculate how much is
Velocity
it velocity is.
and angle. They
Yeah.
calculate two things. The things you told me in the case, you told me two things, velocity and angles. Now, this is the concept. So what is a projectile motion? A projectile motion is an example of a two-dimensional motion, which includes projectile motion is an example of a two-dimensional motion which involves what?
Yeah, horizontal and vertical motion.
Yes, a horizontal and a vertical motion. Look at this. Now, the two important assumptions. Number one, air resistance is negligible. The first, the primary assumption of a projectile motion, the value of G remains constant throughout the motion and there is no sideways or spin motion. Normally, when you hit a football, it is spin also. But we assume there is no sideways or spin motion. The value of G remains constant throughout the motion. My first concept has been established. So can you repeat with me? Can you look at the screen and can you tell me what is the definition of projectile motion?
Projectile motion is two-dimensional motion, a vertical and horizontal motion. And
The concept of horizontal and vertical, you gave me the example of Angry Bird. You gave me the example of football. Do you know that the famous football kick by the goalkeeper which goes all the
by
way?
the goalkeeper that was in football bit due to the wind speed and it reached the other side of the goal. That was a record, yeah.
And how goalkeepers are trained so smartly because they do not raise the ball too much. If you raise the ball too much, then do you think that you will lose horizontal also if you take it too high?
If I take it too high,
It
yeah,
will
we can lose it because, yeah, you
then
can.
it will not go along. A very unfortunate, a very sad example. Now in the world, 2, 3 regions are under war, and these projectiles are used as a missiles. These missiles travel up and then go down. a very sad and unfortunate example, but technology and the concept is the same, that this is a projectile motion.
For
Projectile.
this, yeah, yeah, this is like they you need projectile. You need to know how to do it.
Mhm. So we have made our first concept. What are the important assumptions? Number one, air resistance is negligible. Second assumption, value of G remains.
Value of G remains constant throughout the motion.
Yes, and there is no sideways or spin motion. Now we have discussed it, and you told me that you play football, and I know you. Then, if you are under some training, these coaches are there. They tell you that do not hit the ball always hard. It's not necessary that you have to hit the ball always hard. These good batsmen in cricket, they also know this projectile concept. They sometimes use less force, but they can throw the ball far away. The main parameters of a projectile motion are: number one, launch velocity and launch angle. It means that how high you want to throw it. And a very good example is throw ball. If you have played throw ball, some people like it, some do not like it, but it's a very nice example because you throw it by your hand. So you control the angle, you control the velocity. Now, this is the title concept of projectile. This is the launch velocity, and theta is the launch angle. This is an example which is used for all the projectile examples. How hard you hit the ball and how high you will take it. Some batsmen who use a lot of energy are not able to cross the boundary, but some batsmen who are smart with good ability to knock the ball, they know to control the velocity and the angle. So what are the two parameters? The two parameters of a projectile motion are launch velocity and launch angle. So can you copy this diagram in your notes? Now, can you explain me these two concepts? What is the significance of launch angle?
Launch angle, launch velocity is like the speed that will determine how far will
It will
like
go.
go, and launch angle will tell how
What is the steepness?
steepness. Launch angle will tell the steepness how far it can travel.
Yes, and now comes their favorite topic, something which comes every year in the exam, and that is called resolution of a vector. They like it a lot, and resolution comes in nearly every other topic. The launch velocity is resolved. Now you have to update your diagram. Please copy this also on the same diagram. And just a minute, please. Now the vector is, acha, can you Umar tell me how I got v cos theta and v sin theta?
Because we are finding out the
Resolution.
resolution of the vector. So it's calculated by this.
So every vector which is inclined, has two components,
Yes.
v
Inclined.
cos theta and v cos theta and v sin theta. Now, Umar, look at the screen. ये जैसे projectile will move forward, when it goes ahead, you will see the same resolution. Now, this is the most important concept in projectile motion, that as the ball moves ahead, velocity will have the keep on the same component, but as you go up, the vertical component decreases to zero and vertical component comes down back again, while horizontal component continue as it is. I repeat the concept. Let's connect from here. When velocity is launched, when velocity is started, there are two components of velocity: horizontal component and vertical component. There are two components of velocity: horizontal component and vertical component. Now make this concept here that velocity के दो component हैं. So as you go forward, v cos theta is there horizontally, but v sin theta gradually decreases. At the highest point, v sin theta will become zero. At the highest point, b sine theta will become zero. As the ball begins to go down, as the ball begins to fall, b sine theta increases until it reaches the same value. Until it reaches the same value, which means actually that v sine theta gain its original value. Now in projectile motion, this diagram is critically important. You have resolved the velocity. There are two components. V cos theta is there for horizontal motion. V sin theta is going for the going upward. V sin theta decreases. At the highest point, V sin theta becomes zero. Acha, when the projectile is coming down, V sin theta becomes negative. Now, can you look at this screen? And can you
Yes.
explain back the two components?
So yeah, I can explain. So in this one, it is telling that there are two components of which we are finding out the resolution for the velocities. So what we are doing is that in the positive one, when it is moving towards up, so we are going to do v sine and v cos, both will be positive. And then in here, this is gonna be zero because when it reaches till here, both the components. And when it begins to fall down, the velocity becomes zero, negative, and initially there becomes more and more negative, like both the components. So
Hmm. Good. So V cos theta is taking it back. At the highest point, vertical component of velocity becomes zero. Vertical component first decreases to zero and then increases. Acha, angle will be the same on back. Now, this is a very important concept. Throughout the motion, the vertical component of velocity is affected by gravity and horizontal component is affected by air resistance. So if you look at this diagram, look at this is called horizontal. Who is opposing it? Air. Okay? And vertical component, and who is opposing the vertical component? Vertical component is being opposed by gravity. So I put my next concept for today. When you launch a projectile, v cos theta is opposed by air and v sin theta is opposed by gravity. They take a very interesting assumption which they take throughout the chapter. According to the assumption, air resistance is not considered, so the horizontal component becomes constant. Look at this. This is called the horizontal component and it's not changing. What about the red one? it decreases to 0 and then it increases. So my next concept, I repeat once more and then you have to repeat. In a projectile motion, horizontal component is constant, vertical component is changing.
And this horizontal component is constant and vertical component is changing.
Yes, vertical component is changing.
Yes.
Good. Now we put this diagram, data diagram. You can see, look at this data. Can you see horizontal velocity is not changing 20, 20, 20, 20. Can you see vertical velocity is changing?
Yes, it is changing.
Hmm. So now look at the diagram.
The diagram, yes, I can see the diagram.
The vertical value is increasing.
Yes, it is increasing.
And what is the horizontal?
Constant.
Right. In horizontal motion, there is no acceleration. In vertical motion, acceleration is g. So horizontal motion, acceleration is g. And for horizontal motion, acceleration is 0. Look at this. Look at this diagram, Umar, that acceleration is minus g. In vertical motion, we consider for vertical, we take acceleration as g, and for horizontal, we take acceleration as 0. So look at the diagram carefully and remind, for vertical dimension, acceleration is plus minus g, but for horizontal dimension, acceleration is what?
Horizontal dimension, it is 0.
Yes, now this you have to remember. Now you have already drawn this diagram, so can you also add in the diagram this point? Include this also in your diagram.
Yes, sir, done.
Formula for resultant velocity. Now give the heading, formula for resultant velocity.
Done.
Hmm. Now these are the two components. Look at the formula, Hamad. Sorry, Umar. Vx square plus Vy square. And the second formula is tan theta. What is Vx? Vx is the horizontal component. And what is Vy? Vy is the vertical component. So whenever you launch a projectile, there are two components. One, there are two components when you launch a projectile. Now, can you see this diagram, Umar, that how there are two components? This is called resolution. So please write down the formulas.
Yes. And
Now, Vx is the horizontal component. What's the formula for Vx? Vx is equal to V cos theta. What's the formula for Vy? Vy is equal to V sine theta. What is theta? Theta is the launch angle. Projectile topic is a bit difficult. Why? Because it was not in O levels. And that's why you won't find a connection with O level here. That is why the formulas are a bit different. So look at the formula and copy these formulas also for Vx and Vy. What is Vx? Vx is the horizontal component of velocity.
yes, horizontal component of velocity.
Hmm. Have you copied it?
Yes.
Now we have the equation selection. Now there are two components in a projectile motion. In a projectile motion, there are two components. We can use equation of motion for vertical and for horizontal. We have a limited option. Look, can you remember these equations? V is equal to U plus AT, S is equal to UT plus half AT squared. You remember them? Now, a very important concept, Umar, that all these equations, look at these equations all. These equations are valid only for what? Only for the
Only
these
for
equations,
the
vertical motion.
yes.
So what's the concept? Vertical motion,
Vertical motion S no S half U plus AT. So like for vertical motion, like first initial velocity then final velocity.
okay. Now, one equation for horizontal motion. I hope you understood that projectile motion is an example of a two-dimensional motion. Look at the formula. D is equal to distance, displacement is equal to velocity into time. D is equal to V cos theta into time. What's the formula? D is equal to velocity into time. So this formula, Umar, is used for what type of motion? This formula is used for horizontal motion. I repeat my concept again. Huh? In a projectile, like this is a projectile, there are two motions, horizontal and vertical. For vertical, we have all the equations of motion. But for the horizontal, we have a limitation. We have only one formula for to use on horizontal dimension. So now can you copy this?
Done.
Now, this is a projectile motion. We can launch a projectile on different angles. As we have discussed, angle is a very important factor, 15 degree, 30 degree. Now, Umar, can you notice that if I'm increasing the angle, the horizontal range is decreasing?
Yes, sir. Yes, sir, it's decreasing.
Range. Okay. Now, acha, this is the maximum range. Umar, look at the screen. Can you tell me at what angle range is maximum?
Angle range is maximum. What? Um. So 30.
Hmm,
30 is max.
no, no. I have written the angle.
So maximum is 45.
Hmm. So what is the concept? The maximum range of a projectile is always at what angle? 45 degree.
45 degrees.
Now we move to our next concept, Umar. There are two types of half projectile. Achha, there are two types of question which comes in the exam. One is called full projectile. What is a full projectile? This is called a full projectile, ground to ground. But there are some questions in which you can throw a ball from a cliff, for example. This is called half or incomplete projectile. Look at the screen. This is called half or incomplete projectile. When you are dealing with a half projectile, suppose you are going down, acceleration is positive g. This is called half projectile. Can you identify this? Why I'm calling it half projectile?
Yes. Half projectile because there's no vertical component.
Hmm.
No vertical component.
Now look at this. Can you identify there are two components of velocity, Umar, horizontal and vertical? So in every projectile motion, there are two components, and half projectile means it is thrown from the top and it comes down.
Yes, teacher.
Now look at this. Can you identify this is a half projectile?
Yes. I can't. Okay, I can recognize now.
Hmm. This is called half projectile. Now, let us try a question. This is question number 8. First, you read the question.
First, a stone is thrown horizontally from the top of the cliff. Air resistance is negligible. Which graph shows the variation of time of the vertical component of the stone of the velocity?
Hmm. A stone is thrown horizontally from the top of a cliff. Air resistance is negligible. Which graph shows the variation with time of the vertical component of the stone velocity? The trick is vertical.
It is B.
Mhm. Okay, now I will show you all graphs. Huh? In the first graph, Umar, acceleration is 0. Can you tell me why in the first graph acceleration is 0? Because the line is horizontal, 0 gradient. Acha, what's happening in the second graph?
Second graph is decreasing.
Hmm. Okay. And what about the third graph, C?
Increasing. Um, so I don't know what will it be. I think so. It will be B.
And what about the third one? What's the third one? Third graph shows
Increasing. It's just increasing.
just increasing, constant.
Yeah.
Actually, now look at the question. He's talking about vertical component of velocity. Let me draw a projectile here, and then we can finalize our answer. If I draw velocity V, if I resolve it, is it the horizontal component Vx and is it the vertical component Vy? Is it? There
Yes.
are two question is talking about, Umar, question is talking about vertical component. Question is talking about vertical component. So vertical component is having a constant acceleration or not? Or
Um,
acceleration is changing. I show you the diagram. Look, this is the diagram. In a projectile motion, acceleration is equal to what?
acceleration Be gradient. So it would be D, sorry.
Acceleration is equal to G. What is G? Remember that?
G will be 9.8.
And this value 9.8 is changing or it's a constant?
Changing.
Huh?
That is
Changing.
constants.
Constant. Okay. So let me repeat the concept. In a projectile motion, the vertical acceleration is constant and horizontal acceleration is zero. I show you this concept again. This concept is not fitting in right now. Remember, remember this concept. In a projectile motion, vertical acceleration is g, which is constant. But what is the horizontal acceleration? Horizontal acceleration is zero and vertical acceleration is plus minus g. Plus minus g, Umar, means plus minus g what? Plus minus g means it is
Yes.
plus minus g means it is constant. Now I have explained you this concept again, and I always, as I tell that MCQs and A level are very tricky. That's why if you do few questions, 2 questions, 3 questions every day, you will be able to face them. Otherwise, MCQs trouble everyone. So now can you select the answer?
Okay, I can select
Acceleration is constant.
B. What is D,
Uh,
sir?
Yes, good answer. Now, contribution of time. Now, we move to our next concept, Umar. Time is something which is not resolved. You can resolve velocity, you can resolve displacement, you can resolve acceleration, but time is not relative. Time is the same. If a person is working, if a person is sleeping, time doesn't actually depend on anyone. So time is not resolved. So time for vertical component is the same as the time for horizontal component. Look at this. Horizontal velocity, vertical velocity. Now, this is a very important sheet. Time is never resolved. Time for vertical and horizontal component is the same. Displacement is resolved, velocity is resolved, and acceleration is resolved, but time is not resolved. So, what is the concept? Time is never relative, it's always absolute according to Newton physics. And I know that in Einstein physics, time is not constant, time changes. But here in our normal physics, we say time is not resolved. So can you repeat the concept from the screen?
Time is not resolved.
Hmm. Time is not resolved.
Time is not resolved.
Now give the heading, Umar, effect of air resistance.
Done.
Okay. Now, air resistance is when you play in morning, suppose you will find that air is really a big factor. Sometimes in cricket, the air resistance is even able to change the result of the game. Air resistance is a very big contributor. Now, what they do in the exam, they first say there is no air resistance. So obviously air resistance is ignored. But in the last, sometimes they say no air resistance is present. To look at the screen for the concept, air resistance or viscous drag opposes both the components of velocity. What are the components? Horizontal component and vertical component. What is the net effect due to air resistance? Time of flight is reduced, range reduces, maximum height reduces. I repeat, look at the screen. What is the effect? Acha, examiner, if examiner says air resistance is there, then you will mention this. Time of flight is reduced, the ball will come down earlier, range is reduced, and maximum height reduces. Look at this screen.
Okay, time of flight is reduced, range reduces, maximum height reduces.
Hmm.
Time of flight is reduced.
Now I'm putting a summary of this topic. Projectile motion is an example of uniformly accelerated motion in one direction and uniform velocity in the perpendicular direction. So remember this concept, Umar, that projectile motion includes two dimensions. What are the two dimensions? Horizontal and what are the two dimensions? Horizontal and vertical. In a projectile motion, there are always two dimensions. One is called horizontal and one is called vertical motion. So whenever you get a question on projectile, look, this is the appearance of a projectile question. You have to be very careful because projectile questions are different from regular kinematics questions. You have to remember that in projectile, there are two velocities. I repeat, in a projectile motion, there are always two velocities, and you have to be careful in solving these questions. You first have to remember that you have to resolve. So let us try this question quickly. Orally also it works because the time is getting less. So, but you have a book now, so you can also, this is June 20. Can you bring your book? You have the book, I think so, right?
Bringing it. I
Paper
don't have.
two book. Can you bring your paper two book? Have you brought the book?
Yes. Got it.
So can you open the book Kinematics and state Newton's law of motion? Time is very less. I think if you see on the screen, that will also work. I'm not sure if you can find the question. Have you used this book now? Because if you're habitual, you can find it. If you open the kinematics chapter,
Yes.
and this is June 2020 paper, June 2020. Look at the screen. You will look this image. Scroll the pages around 2020 year number, and you will see this image.
Page number?
No, I cannot change. I cannot give you the page number. Actually, the books are different. Na? These books are printed every year, and different editions are there. Different publishers are there. I can tell you the year number. Can you look for 2020, June 2020? You can see in the book, in every question, there is year number.
Yes.
So can you flip the pages and see June 2020, S 2020? I'm waiting, Umar. Are you getting difficulty in searching this book?
Yes.
Year number is there on every question. Actually, leave it. Look at the screen. I think this book, you're not still habitual of this book. Look at the question, please. A delivery company suggests using a remote control aircraft to drop a parcel into the garden of a customer. When the aircraft is vertically above point P to on the ground, it releases the parcel with a velocity that is horizontal and of magnitude 5.4. The path of the parcel is shown. Can you look at the screen? Is it a projectile question?
Um, yes, this is a half projectile motion.
Yes, very good. Now, can you look at the screen that he says the parcel takes a time of 0.81 second after its release to reach point Q on the horizontal ground. Assume air resistance is negligible. Can you read the question yourself? Not loud, but can you tell me what's happening here? What is the story?
Yes, teacher. So it's gonna teach is negligible.
Okay. Now, have you read it? Now look at the first part. Draw an arrow point X to show the direction of the acceleration of the parcel when it is at that point. Where is point X? Parcel is coming down or going up? Parcel is going down or coming down or going up.
Coming down.
So look, he's saying mark the acceleration. Look, acceleration will come like this. Why downward? This is acceleration. Why it is downward, Umar?
But it will be down because it will be down because the gravity.
Yes,
Gravity
very
time.
because parcel is coming down. If something is coming down and gravity is pulling down, the acceleration would be down. Okay, now read the question. Next part, part two.
Determine the determine the height of the parcel. Draw an arrow of x. Determine the height above the ground when it's released.
Hmm. Determine the height of the parcel. Determine the height of the parcel above the ground when it is released. So look at the question. Is he asking this height? Is he
Yes,
asking this height? And in the downward motion, acceleration is equal to plus g.
yes, plus
This,
G.
this is the Vx. And at the highest point, the vertical component of velocity is zero. At the highest point, the vertical component of velocity is zero. And how much that time is given? Look at the time. I have made an arrow.
Yes.
How much
So
is the velocity?
0.81,
Now, Umar, please look at the data. U is equal to Vy is equal to 0. A is equal to plus G plus 9.8. Please copy the data with me quickly. Time is equal to 0.81 second. I need to find the distance or the height. Please copy the data. Tell me a suitable equation of motion. Yes, Umar, I'm waiting.
mm,
Have you copied the data?
I did copy.
So can you see the equation of motion? I've recently posted the poster also and select a suitable equation to find S.
It will be as it will be as um u yeah, s u t plus half at square.
Good. And SU is 0.
Yes.
And what is acceleration?
But
9.8.
acceleration 9.8 and time is 0.81.
Now please copy with me the solution. 0 into t will become 0. Now can you take up your calculator and solve it? I'm waiting.
0.21.
But you have to increase your calculation speed, Umar. 0.21 meter. Okay, that's good. Acha, the class is over, but I want to discuss a quick thing. Are you still not able to get this book because you have purchased this book? Because whenever I ask you search for a year or something, is this book in a proper order? Like I know because you got it from here. So can you please open the book for kinematics again? Can you tell me that how this book is arranged? Is it in ascending years or descending years?
Ascending years.
So it starts from 2016.
Yes.
So can you scroll over? I just want to check the book now. Can you scroll over the book? Can you move forward from 2016 and keep on going and reach 2020? Can you do that?
You're doing
Be-
it.
Keep on flipping the pages, see the years.
Sir, this book is like varied. Some parts you can find 2020, some parts,
Please
some
tell me.
parts is some parts is like 2020. I got one paper 2020.
Hmm.
So
That, and
ye-
it's a different question.
yes,
Oh, no problem. But you got 2020. Acha. Any other 2020 there in the book? If you flip the page, just like what I want to say, look, actually, I want to ask you that obviously the book must be in going upward year or going downward year. 2016. Is it going from 2016 to 22 or 2022 to 2016? This is what my
2020, 2016.
is coming down.
Yes,
Okay. So can you look for any other 2020 questions? Acha, look, I got the issue. This book has made a separate section for projectile. Can you come on the content page, Umar? Can you come on the page of contents?
yes, I
The
can.
Can you see there is a separate chapter on projectile motion?
Yes,
Good. So this is actually the problem. Now, okay, fine. So please try to get familiar with this book. So we can do we can select past paper quickly. So we are stopping here and we will inshallah continue in our next class. Okay. Thank you. Allah Hafiz.
Love this.